Creating scalable applications can be tremendously difficult. Even if we try to implement patterns and practices to make this easier by, for example, introducing a queue or a message bus to let us decouple different parts of the system. If we were to use something such as the Azure Service Bus, this would definitely be a great service to allow us to add messages onto a queue and for subscribers to subscribe to those topics and handle whatever message is put on that queue. And just like other Azure services, this promotes high availability, is scalable, and should potentially solve a lot of our problems. Although, one of the headaches that a lot of developers have with introducing the Azure Service Bus, and something that's frankly been a problem for a very long time, is how do we build this application locally without relying on the cloud when building that application? The problem with the Azure Service Bus is that it always required that we had a cloud service available and for the local developer to connect to that cloud service in Azure to be able to develop the application. My name is Philip Ekberg, and let's take a look at the Azure Service Bus Emulator, which hopefully makes this work a lot easier. Normally, when building an application that requires the Azure Service Bus, you go ahead and set that up in Azure. But the problem with this approach is, of course, that if I don't have an internet connection or I want to work offline, then I don't really want to be able to rely on the cloud to continue my development. There's also the problem where I might be working on a certain feature in the application, publishing messages onto the service bus, and then suddenly another developer working on something else in the system starts getting messages about stuff that's happening on my end. That can be quite confusing, and while there are ways to solve this, and there has been ways to solve this in the past as well, offering a local developer experience would be a much better approach. Therefore, there's now something announced called the Azure Service Bus Emulator. The Azure Service Bus Emulator offers a local development experience and emulates the services available in Azure. Of course, this is not supposed to replace the Azure Service Bus running in the cloud, and you shouldn't host this for a production environment. Its sole purpose is to make it easier to build those integrations locally without relying on the services running in Azure. The benefit is that you don't have to set it up in Azure first, and you don't really have to spend a lot of money having those resources running in the cloud. There's a lot of benefits here, but how do we actually get this to work? Let's take a look at how we can set this up locally. The end goal is for our application to be able to point to this local emulator instead of relying on what's running in Azure. The Azure Service Bus Emulator comes with a repository that tells us how to set this up. There's quite a few steps to get this running, but it's not really that complex. There's instructions for how to do this on Windows, Linux, and Mac OS. So basically, this will allow you to work on any different system that you're comfortable with. If we take a look further down at the scripts here, while it asks you to accept the end-user license agreement, it also just uses Docker Compose to set up a couple of containers. If we take a look at the Docker Compose file, this requires SQL Server, and of course the emulator container. The emulator will use SQL Server to store the messages. This is simply an emulator to talk to the Azure Service Bus. If you're using the libraries in .NET to communicate with the Azure Service Bus, you should be able to simply replace a connection string, talk to this emulator, which will then store those messages in SQL Server. All of this looks very simple. Although, I don't really want to use that Docker Compose and the YAML stuff, nor do I want to clone the repository and run that startup script as instructed in the README. How about we do this in .NET Aspire? As we talked about in the previous video, .NET Aspire in fact allows us to run Docker containers. It will allow us to orchestrate different types of containers in different applications, and this is a perfect opportunity to look at how we can transition from Docker Compose into .NET Aspire. One more thing. I can see that this here is using the Azure SQL Edge container. This is actually deprecated. There's another container that we're going to use instead, which is already supported by .NET Aspire. Let's jump over to Visual Studio and start coding. Since I know that this here is going to rely on SQL Server to be running, I'm going to install aspire.hosting.sql server. This will allow me to very easily set up a SQL Server Docker instance that will be managed by .NET Aspire. Once that is installed, I can go ahead and tell my builder here to add SQL Server with a given name, and I'm going to determine exactly which port this runs on. I'm also going to determine that the lifetime of this container is going to be persistent. Next up, I'm going to set up the Service Bus Emulator. I'd like to take what I have inside the Docker Compose file and translate that into what I can write for .NET Aspire. I'm going to say that we're going to add a container with a given name. The image will be exactly the same one that I find in the Docker Compose file, which is the Service Bus Emulator. Then, I'm going to add a reference. Because the Service Bus Emulator relies on SQL Server, I need to be able to point to that particular instance. In the Docker Compose file, this was quite easy because it pointed to the name of the other container that the same Compose file sets up. This isn't really possible to define exactly the same way using .NET Aspire, but I'm going to say that my container will have a reference to the SQL resource primary endpoint. This will allow me to point to that particular endpoint running in the app host. Then, I'm going to say that my Docker container for the Service Bus Emulator is going to be on one particular port, and that's going to have a target port inside the container as well. We can also give this endpoint a specific name. I'm also going to pass in a couple of the parameters defined in that Docker Compose file. Accept the end user license agreement. I'm going to point to the SQL Server instance, which is simply now pointing to that SQL resource primary endpoint. Then I'm going to specify a very secret password for MS SQL. Finally, I'm going to mount the configuration JSON file into this container by using with bind mount. This will bind that configuration into the root of our container. I'm going to add that config.json file to the project and ensure that this will always be copied, so that .NET Aspire will be able to map this into the container that it now spawns up. This will let us set up the queues and subscriptions and topics and all the different configurations for our Service Bus Emulator to work properly. I'm going to leave this as what I found inside that GitHub repository, but you can go ahead and configure this in whichever way that you'd like. If we were to run the app host, this would now bring down both the SQL Server Docker container as well as the Azure Service Bus Emulator. The Azure Service Bus Emulator now connects to that SQL Server, and the Azure Service Bus is now just waiting for messages to be sent to it. Now I want to be able to consume my Azure Service Bus. And ideally, I install the same package that I'd use for talking with the actual cloud resource and use the same APIs. The only thing that should be different is the connection string. Therefore, let's go to the Blazor application, which is the web frontend. It doesn't really matter which type of web frontend that you're using or whatever backend you're using. This will be quite similar. I'm going to install Azure Messaging Service Bus, and once that's installed to the web project, then I'm going to add a page that handles messages. The code here could potentially live in a code behind file instead of in the Razor file, but this is for demo purposes. I'm going to add an observable collection of messages, which I can then iterate through inside my Razor page. Once that's added, I'm going to add a Service Bus client. The Service Bus client allows me to set a connection string. I'm going to hard code this to point to localhost on the port that I specified in my app host. I could, of course, have this automatically injected by .NET Aspire, but to make this simple and to focus on the important parts, I'm going to hard code this to the actual connection string that I know that we have here. This is similar to what you'd have in Azure, but in this case, pointing to my local emulator. Once .NET Aspire will get official support for adding a configuration for the Azure Service Bus Emulator out of the box, we probably don't have to manually set the endpoint and manually map the configuration like I did earlier. But that's probably something that's coming later. I'll introduce an asynchronous method that allows us to create a sender and send messages on to that service bus. I'll just send a service bus message, and whoever listens to the service bus will now be able to handle that properly. I can bind that to one of the buttons in this interface, which will now let us invoke this method if we'd like to. And in the same way, I'm going to add a method that starts reading or streaming information from the message bus. This method will create a receiver and listen for the same queue and use an await for each to asynchronously read the messages that are added to that queue. As soon as a message is sent to the queue, it will then be populated and passed into this for each loop. So this will in fact go through that Service Bus Emulator and then be received in this application, which is quite amazing. So hopefully now when I press F5 and run the application, this will work. In the .NET Aspire dashboard, we can see that all the services are running. We have our SQL Server, we have the Service Bus Emulator, we have the web frontend. And as I navigate to the web frontend, go to that messages endpoint, send a message, receive messages, and send a couple of more messages, that will start populating into the application. This is quite amazing. I don't have to introduce an Azure resource running in Azure. I can now build a decoupled application that relies on an Azure Service Bus. I can do that locally without that resource being available in Azure, which hopefully makes my local development a lot faster. And saves me money as I don't have to pay for an Azure resource running for simple development purposes. I know that this is something that a lot of people have waited for a long time. Being able to emulate the Azure Service Bus and do that locally for every developer machine. You could even point to a shared SQL Server instance if you'd like to share those different messages. But the idea is that we can build this locally without having that requirement of being online or requiring us to connect to Azure or even paying for that resource until we are going to production or publishing the application for testing. Hopefully this is going to speed up your development process. I'd love to hear about your story around using the Azure Service Bus. I really hope you like this video and that you're going to experiment with the Azure Service Bus Emulator on your own. If you liked the video, leave a like, subscribe to the channel, and leave a comment if you have any questions. My name is Philip Ekberg, and I'll see you in the next video.